Hey everyone, my name is Dominic. Hope you guys are all doing very well. Really glad that you guys can all join us for this webinar on distributed authority. We're just going to take a couple of minutes and just kind of wait for people to come in, everything to get started. While we're waiting, does everyone want to just start by saying like where they're from, say hi to everyone, just kind of see where everyone's connecting from? I'm coming in from Alberta, Canada, and yeah, hello to everyone out there. I see we've got Germany, Austin, Texas, Helsinki. Ooh, everyone all over the world. Hello, Australia, Costa Rica. Wow. Turkey, India. Nice. Just heads up as well. I believe that there's a poll just to kind of get some information about participation, who's joining things. Feel free to fill that out if you want. Hello to fellow Canadians as well. Hello, hello, hello. Thanks for joining. Thanks for everyone coming in. I think we're just gonna still wait for a couple more people to come in. I'm sure someone can post the poll link in chat. There should be something that's coming up. Wonderful. I think we have about 166 participants. Wow, it's quite the turnout today. More Australia. Oh, decent amount of Australians. Hello, everyone. Just a heads up as well, this is going to be recorded and the recording is going to be sent to everybody. So don't worry if you missed something or if you didn't catch something or want an extra refresher, like everything's going to be available, sent back out. So don't worry, we're going to make sure that we take care of everything there. Yeah, poll is back up, so feel free to go fill that out. Great information for everyone. Thank you for everyone who has participated and is going to participate. So I think we've got about 180 people in at this point. So I'm going to go and start things off. So bring up my slides here. I hope everyone can see my screen. So welcome. We're doing a webinar on distributed authority for client-hosted multiplayer games, but really distributed authority, the netcode, more information about what's going on, and hopefully really sort of give you a bit of a kickstart into the distributed authority world and the new features that we're offering here. A little bit about myself. My name is Dominic. I'm a senior developer here at Unity. I've been working on distributed authority sort of since the inception, mostly doing back-end sort of technical work, a lot of netcode engineering. We also have, I believe, Noel in the chat. He's going to help with QA, another major developer on the project. So feel free to ask any questions, interact in the QA panel. We're here and happy to help out. A little bit about what we're going to talk about today. I'm going to start with a bit of an overview, get everyone on the same page, talk about what distributed authority is, why this matters, what's the value, stuff like that. Then we're going to start to deep dive, and we're going to go into some of the more interesting bits, talking about object ownership, what that means, what controls you have, stuff like that. Scripting references, we're going to throw up some code, show you what you have to do as a developer, what's important. Then we're going to move on to some of the really juicy bits. So host migration, which I think is one of the killer features of distributed authority. We're going to dive into that, see what's needed, what matters. Talk a little bit about the back end, some of the services and tools that help support all of this. And then finally, we're going to do a little bit more live QA. So you can go ask questions anytime. My colleagues will be answering in the QA chat. But at the end, if there's something that we want to talk more live about, we'll have a little bit of time to do some back and forth and really dive deeper into important topics for you guys. So I hope that's all great. And with no further ado, let's dive into it. So let's start talking about distributed authority and what it is. So exactly, what is distributed authority? Well, it's a new network topology. So you may be familiar with network topologies. Traditional ones would be client server is sort of the most classic. You have a server somewhere up in the cloud. You have a bunch of clients that connect in. Server runs the game. Clients do the updates. Everything runs that way. Peer-to-peer is another one that you might be familiar with. This popular where you might want to have a host or something like that, spread things around. Distributed authority is a new network topology that we're introducing now, and that is coming to NGO and Unity and everything like that. And the way it works is it actually is able to share the entire simulation. So different clients run different parts. Everything gets shared across to make sure that everything works. And there's no single load or single server anymore. It's pretty low complexity. There's no servers. You don't really have to think about that. There's no configuration. You don't have to worry about builds, uploads, all that sort of management stuff. And it's high reliability. So we're going to talk more in detail about this later, but host migration is a really cool killer feature of distributed authority and make sure that everyone stays connected even if you're having network difficulties. So you might be asking why you might be interested in this. Well, there's a couple of really key benefits that you get in it. First is versatility in authoring. In one sense, you don't get locked in. Distributed authority is just a new concept, but you can use as much of it or as little of it as you want. So you can really still have most things on one client, or you can really spread it out depending on the needs of your game, depending on how things run. And you can even change that at runtime. So we're going to talk a little bit later about it, but you can really see that the power is more in your hands, whether you want to spread things out, keep them close, and how things want to be spread. So you have a lot of versatility. It's cost effective. We know that running servers in the cloud are expensive. You have to, sorry, my mouth is getting a little dry here. That's better. Running servers in the cloud is expensive. You have to have builds, uploads, server costs, all that sort of thing. Distributed authority keeps things on the clients. Clients are a lot cheaper. It's much more cost effective. It handles all the connectivity that you need. So out of the box, you can handle a bunch of connectivity scenarios that we know are kind of hard to set up. We just make sure that everything connects and it just works. That's really our goal here. So connectivity is something that we really pride ourselves on making easy for you. And then flexible scalability. You want to make a game that's successful. And a successful game means scalable, right? You need to have support for a lot of different clients. Things need to get big. Things need to become world scale. We offer that out of the box. It's not something you have to then figure out later. When you're in distributed authority, works small, works big. You don't have to worry about how you're going to scale when you're potentially successful or anything like that. We're just going to handle that for you and continue to grow as you grow. So I talked about this a little bit earlier, but I like to really think about network topologies as a spectrum. There's a range of things with various trade-offs that you might want. So on the left, I put sort of I would say simplest network topology, just in terms of a concept. So we have peer-to-peer. On a peer-to-peer, you have a bunch of clients connected. Say you have 3 computers. One of them is hosting. So one of them is actually the server, but we just don't say that. And everyone else connects into that host. Maybe they connect directly, maybe they connect over a relay, and that just makes sure, and then that game runs, and it has some benefits. So the host is the authority. It's not very complicated for network complexity terms. You have it set up, the host is running it, everyone else is connected, game server runs. You don't need an extra computer, you don't need special builds or anything like that. Unfortunately, it does have some reliability issues. If your host has a weak computer or is on a bad network or just happens to be in a weird, like opposite side of the world, something like that, you're really going to end up suffering. Like every single client is going to experience that connectivity issue across the whole system. On the other spectrum, we have sort of the big iron traditional high complexity servers that you would expect from any sort of game, and these would be called dedicated game servers. So in this case, the game server isn't running any of your game as a client. Nobody's playing on the game server. Everyone's connected to the game server, and it's just handling the game and sending updates to everyone else. Usually this game server would be running on the cloud somewhere. It's up, it's scaled, and you're paying for it as a developer. So the servers are costly, they're hard to set up. It also requires like build management, uploads. They're fairly complicated to work with compared to, say, peer-to-peer. They're also really reliable. So you get rid of all that networking stuff. You can have high reliability networking, strong pipelines, locate them anywhere in the world, and you really like get the best networking possible for the best experience for your players, but you're going to pay for that. Now, distributed authority, we kind of aim in the middle. We want to try and take some of the good parts of a dedicated server, some of the good parts of a peer-to-peer host, and mix them to come up with something that works a little bit better for, I would say, an average scenario. So we have shared authority. The clients own parts of everything, but not everything all at once. So that really makes sure that risk is reduced, right? So you don't have to worry about a full disconnect or anything like that. It's still got the low complexity of a peer-to-peer host. There's no special builds, there's no special uploads. Everything just kind of flows as you would normally expect. And it's more highly reliable. And you'll see with host migration, it's really the special sauce, but any single client can't tank the whole system for everyone else. So there's a lot more reliability baked in. It's a little bit more stable for everything involved. So a step up from peer-to-peer. Now, how does it work? So there's a couple of different pieces, two main bits that we pair together to really make this system function as we intend. So we have the distributed authority service. So there's a service in the cloud that's running that powers the sessions and the connectivity and the core parts that every single distributed authority system needs. Starting, handles connections. So connection comes in, player comes in, we're going to check things that you obviously need to care about, which would be like authentication, authorization. We make sure that the right people connect to the right systems, the wrong people don't get to connect. It then manages certain rules like ownership, making sure that the right clients can perform things and that cheaters can't, or that you just make sure that everything really stays owned and controlled by the people that you want. This is part of the distribution. And it routes messages. So it is a router. Make sure that all the messages get across. It's kind of like a relay, keeping everything in sync and handling all of the networking and messaging that you would expect. With that, we pair distributed authority clients. So your client does need to be distributed authority aware. And the way that it works is the different clients connect. They will be given parts of the simulation. They run them, and they handle their state and their authority depending on which part of the game they're on. And together, they all build up this distributed authority server. And it's together that they all create sort of a host in a simulation as it's all combined. That's great. These are a lovely bunch of slides, and I can talk about what it can do, but we all like seeing. I know seeing is believing, so why don't we just pop into a little bit of a demo? Now, it's a live demo on a webinar, so please, demo gods, hope this all works, but I'll see what I can do here. So I'm going to open up a Unity instance here, just standard project. And this happens to be our Distributed Authority Social Hub project. It's a distributed authority enabled project that's available as a sample that anyone can use and really just try it out. You can go load this, play with distributed authority, build it up as you want, and it's available for everyone. I'll go into more detail about that later. I'm also going to be using multiplayer play mode. This is a tool that's available for developers that makes it easier to run multiple clients locally and really just test your systems. So I'm going to pop this over onto the half screen and hit play. And you can see we've opened up 2 instances of our app. For now, I just need the first one. So I've got player 1, and we're going to just connect into the demo session. So right now it's doing all the connection, figuring out the best server, launching everything, connecting up into the cloud, and we have our game. Notice there was no build, there was no upload, there's nothing behind the scenes. It's just open, play, connect into Unity, everything works. So right off the bat, simpler system. We can see I have a little social hub, cute little piggy guy walking around, and there's some stuff I can interact with, pick up, drop some boxes, stuff like that. Now, there's more going on behind the scenes. We know this is distributed authority. We know this is netcode. So I'm going to pop over into the scene viewer, and I can see a little bit more about what's going on. Notice right away that we have this coloring on things. So this is the network visualization tool, and I'm showing ownership. So this is a concept and a term I'm going to talk about more, but you can really see everything is single color. These are all the network objects, and they're all being run by the same player. Now I'm going to connect in my next player, my second player. I'll put back to the game just to have some suspense. But let's connect player 2 to the demo. So it does the same process, goes, connects in, and we have our player 2. Player 2 is synchronized, player 2 walks around, everything that you would expect, just works like a regular multiplayer game. But if I go back to the scene viewer, we're going to start to see some of the distributed authority features in action. You'll notice here that I have 2 colors now, one representing the player 1's client, one representing the player 2. So I believe on the left we have magenta, on the right we have this teal. I'm sorry if it's the wrong colors, but I'm not a color person. And you can see here that we've actually not only have the players being different colors, but the boxes as well and different parts of the system. So the system is recognized, we have 2 servers, 2 clients connected in, and we're going to split this up. So immediately, it's automatically made sure that the 2 different players have different access to things and everything still works. So that's sort of a basic. Let's go back into the slides, talk a little bit more about this in detail, and then we'll go back into some more demos. Just hide that. Wonderful. So you saw the different colors in the demo. This is super important. And what this is this knowledge or this concept of ownership. Everything in distributed authority revolves around ownership, and more specifically, authority. Authority means that you can do certain special things to a network object. If you have authority over an object, that means you can spawn and despawn it. You can create them into the world, remove them, anything that you need there. You can change parenting, move it around the hierarchy, stuff like that. And you can change ownership. So you can actually change the authority of an object if you have authority over it. You can also do updates and the various other things, like move it around if it's a network transform, stuff like that. Traditionally, in a client-server topology, think network dedicated game servers or peer-to-peer, there's only one point of authority. Either the host has authority or the server has authority, and everyone else doesn't have authority. This is kind of the mental model that we get into when we start to talk distributed authority. With distributed authority, we're breaking this idea. We're saying multiple people can have authority of different parts of the game, multiple clients, and this is super important. Ownership is our sort of model of that. So if you have ownership, you have authority, and the authority is distributed amongst the different clients. So distributed authority, ownership leads to authority, distributed ownership. With that, you as a developer have control over this. So this is the sort of new addition that distributed authority brings, and the thing you need to think about when you're developing your distributed authority game. Every single network object has ownership rules. And these ownership rules dictate how the different pieces are, or how the authority model runs on these different pieces. So you can set it to none. And if it's set to none, it's going to operate just as normal as you'd normally expect. And this is the default. On top of that, you can turn on a couple of different rules for each different object. So distributable is the first one. And that's the one that we saw in the last demo. So distributable means, hey, I've got this object. You can, I don't care who owns it. I don't care who runs it. Please spread it around to balance the simulation. And it tells the service to go do that. So that's going to pass up and just be controlled by the service. We also have transferable. Transferable means I might own this, but someone else might want to own this, and I'm okay with that. So you can transfer ownership between different clients. So if you say that, like, I don't know, a box or something you can pick up is transferable, then when someone picks it up, you might want to transfer that ownership and have them own it for the time being. And I'll explain a little bit why that's valuable in a minute. And then finally, request required as well. I see some people posting about hacking in the chat. This is a way to like slightly alleviate that. And what that means is you can have ownership, you can take ownership, but please ask first. And I'm going to manage it that way. So we can send it through, have a little bit of a back and forth and say, you might want to own this, but I want to decide whether I'm going to let you own it or not. Depends on your gameplay needs. And then every single client needs to follow these ownership rules. And they're also enforced by the server. So you can't really break them. It just depends on how the developer has set them up for their game to take advantage or to pull back depending on the needs. Now, Object distribution is kind of key. Well, it's part of the name, distributed authority. When an object is distributable, it means that we're going to start spreading it around as new clients connect. This is exactly what we saw in the demo. And it's very valuable for you as a developer because it helps simplify your networking and reduce sort of the overall cost of things for different clients. So when it's balanced, we can see here that the first one, client A, player A, there's only one object and they own everything. And then the second client connects and they own half and half. Let's say everything was distributable in that case. You have a lower upstream bandwidth per client. So every object you don't own is updates you don't need to upload. So it's going to reduce your networking cost upstream as things distribute out. And you'll see that tick down with different clients. It also lowers your simulation cost. So there's less computation to be done per object if there's less objects you need to compute. So it reduces the amount of CPU usage per client as things distribute out more. The more clients, the better you get out of this. A bit of diminishing returns over time, but when you get 2 clients, it's half. When you get 3 clients, it's a third, and so on, assuming that you've distributed your objects quite nicely across the game. And they're still synchronized. So every single client still gets all the updates. They still pull the new data. That's still going through. So unfortunately, we don't lower the downstream bandwidth, but upstream bandwidth is lowered as things distribute. Then, as I mentioned before, we might want to make things transferable. And the reason that we do this is to start to enable 0 latency per client, depending on the needs. Spawning is a really good example of this, so I'll go into a little bit of detail. But let's say you had a game like some sort of spaceship thing, and you were firing lasers. So you have a spaceship moving through space and a laser that's firing. If we didn't have ownership and a server was managing everything, that is actually a really hard problem. If you did it naively, your spaceship's moving, you tell the server, I'm going to make a laser projectile, please spawn it. It's going to spawn in the past. Your ship would move, and by the time the server creates it, your ship is already out of place, and you end up with lasers and stuff that aren't where they're supposed to be. With distributed authority, that's fixed because the laser can be owned by the person creating it, and you get rid of that network latency between the server and the client. So the ship's moving, creates a laser, everything stays in sync, and everyone else just sees that in sync. So it really keeps everything together, close, and make sure that the network latency can be worked around. You can't fix network latency. There's always going to be internet latency, but you can work around it by transferring ownership intelligently to make sure that things that need to be in sync are in sync and things that don't need to be in sync aren't. In addition to that, we've also added a new feature called deferred despawning, which tries to alleviate the opposite problem. So just because things are spawning in sync doesn't mean they despawn in sync, and despawning does always incur some network latency. So we have a deferred despawn system that allows you to say, actually, we're going to wait a couple of ticks, despawn it out, calculate network latency for us, and handle it there. So with these 2 tools together, with object ownership and transferring and deferred despawning, you can really make sure that your simulation is accurate for all clients, and you don't see this desync when things need to really align together. So let's go back into the demo, and I'm going to show you a little bit more about the controls on ownership and how we can use that in gameplay to really make sure that things stick. So I'll go back to my demos here. Same app, nothing's changed. It's still the Social Hub sample, loading it up again, and I'm going to load up still with 2 players. So we'll do player 1, and in this case, I'm just going to call the session demo 2. You can create whatever sessions you want. The naming doesn't really matter. You can also use Matchmaker or other tools that you would expect to use from Unity, and it all just works together. I've got my player 1. We'll do player 2 connecting into demo 2. Let everything connect. And we have our little system here. Now, what's going to be interesting is if I pick up this box with player 2, you'll notice that the box itself is perfectly tied up with the player, right? If I move around, you don't see the network latency. You can see the difference between the 2. So player 2 is a little bit lagged behind player 2 on the left screen versus the right screen. but they're always perfectly in sync with the box. And the reason this is because player 2 owns both the player and the box object. So if I go into the scene view here, you can see that they're both the same color. So player 2 has control over that box. Now, if I go back into the game and I drop the box and I let player 1 go grab it, we still don't have that network latency issue. The two are still perfectly in sync. The box isn't lagging on the other system or anything like that, even though player 1 used to be owned by the different thing. And that's because I've marked it as transferable. So when I picked it up, I've transferred the ownership across. And if I go into the scene, you'll see that they're both the same color again. And I'll just drop it. And we can see this in real time as well. If I'm looking at the inspector, player 2 coming around, picks up the box. You see here, we've just transferred the ownership and everything stays synchronized. So it's really a tool that you can use to keep your simulation synchronized, keep everything working as you'd expect, and alleviate that pesky problem of network latency to keep it all nice and together and stepped, and nothing sort of rubber bands or lags out as you would be sort of worried about seeing. So I hope that was pretty visible. You can also see here, if I go into my prefabs, it's all controllable in the editor, in the inspector. I believe under, say, physics, props, chest, I can open this up, go to the inspector. Oh, that's the wrong one. Chest, carryable object, go to the inspector. You can see we have the network object tab, and we've set the network ownership rules. And just like you'd expect, it's distributable, just like we saw that things distributed out, and it's transferable because we can see that they were able to transfer them between each other based on gameplay needs and stuff like that. So I'm going to go back into my slides now. Closing that off. So that's all well and good. But what does this look like for code? I know if I see something like this and I'm looking at networking, I'm getting scared. I'm like, oh, this is more complicated. There's going to be a lot more code to write. Everything's going to just like, I have to be a genius to work on this. And we really tried to get that the other way. And I'll show you how with some scripting references here. First of all, we know and we understand that the connection process and sort of the game connection establishment process for networking is not the simplest thing. It used to be like 500 lines of boilerplate to get a basic networking game working with join codes and relays and all that sort of thing. So we've really worked hard to simplify this. The way we've done this is that we are using our new Unity multiplayer SDK and integrated distributed authority as a first-class citizen right in there. So all that's needed is like 4 lines of code to set up a distributed authority system, as opposed to the hundreds that you used to need. First of all, you can see here, you just got to log into Unity Gaming Services. So we use the authentication service. I'm using an anonymous sign-in here. You could be using first-party sign-in for platforms, consoles, your own third-party sign-in. It's extendable, whatever you need. Just make sure that you do sign in. We do enforce that and make sure that everything works. And then you just start a distributed authority session. You'll see here, with distributed connection. That just means that we're using distributed authority. We want to enable it. If I got rid of that line, it would connect in with maybe peer-to-peer, and you'd hook it up that way. But it's just that one little line extra onto your multiplayer session. Distributed authority is going to get turned on. You're going to start to be able to use that. And it's just create or join session. So it's 4 lines of code to go from nothing to an established connection that you can have multiple people joining. It's that simple. And it's really something that we've worked to make easy to experience and easy to use for all development going forward. We've also worked a lot on the authority model. You've heard me talk about authority. It's really important. And we tried to simplify the concepts. So if you're used to NGO in the past, you would be used to writing code that says is server, is host, is client, all that sort of thing. And I know I was worried about introducing yet another one, like is distributed authority owner or something like that. We've simplified this down. So you only have one concept to worry about now, which is authority. And you can check has authority or doesn't have authority, and that's it. So instead of is server, check has authority. This works in dedicated servers. This works on peer-to-peer. This works on distributed authority. So In a dedicated server or peer-to-peer, if you're the server, you have authority. If you're not the server, you don't have authority. That's all that's needed, and it still works. If you're in distributed authority mode, then your has authority is a little bit more complicated. We're going to be checking per object, do you have authority over this one or not? And it can balance out depending on how the simulation is distributed, but it works the same in all the same cases. So there shouldn't be any code changes needed when you're switching topologies, as long as you're using the new has authority model. Same thing here, more has authority. There's no more is server, stuff like that. Network variables, network transforms, all of the out-of-the-box tools that you would be expecting are authority aware. So those will just work. You don't have to make any big changes about that. They're going to manage the authority and checking as you'd expect. In addition, we've simplified certain things like spawning. So you heard me talk about network latency, spawn synchronization, stuff like that. In the past, the way you would do this, let's say this is a little weapon and it's going to create a projectile that's being fired. Instead of being is owner, we're using is has authority. And you used to have to go tell the server that you want to go spawn something. So you'd have to go create an RPC, send a message that would go over the network, hit the server, and that server would then say, okay, I'm going to create this object and tell everyone that we're creating this object and so far. With distributed authority, you don't have to, because you can spawn things and you can spawn them exactly where you want right away. So no server RPC. What you do instead is you just create the object that you want in the code, directly inline, create an instance, get the network object component, put the positions right, spawn it. It will show up, it'll synchronize, the rest will be handled automatically. And it'll even potentially change ownership if it's distributable, stuff like that. Like it just will handle it, and you just handle it as if it's regular synchronous code on the client, instead of having to think about, oh, do I have to send a network RPC, send things over the network, stuff like that. That's about it for the sort of major code changes, but we've talked about stability. I've been saying that this is a more stable system, that you're less likely to have things crashing and whatnot. And the real secret sauce, and the thing that I'm the most excited about, is host migration. So host migration, we know that host disconnects matter. Like if you're playing peer-to-peer and your host disconnects, everyone disconnects. So that's really sort of an unfortunate issue with the network topology. Same with dedicated servers. They're designed not to disconnect. They're placed in places that are really important. But if it crashes, if your dedicated server crashes, everyone's done. That's it. And hopefully they'll spawn up another one and start a new session, but it can be really frustrating. So it's really detrimental to your users. We don't have a host in distributed authority. We have something similar. We call it a session owner. It's host-like, but it's not. The difference between a host and a session owner is the session owner does a lot less, and it also isn't as important that it stays alive. There's no real risk to being a session owner in the same way that there's a risk to being a host. It has control over things like scene management, making sure that scenes transition as you're working through your game, and synchronization of new clients. So when a new client joins in, making sure that they get all the information they need to be up to date. But we can handle disconnects of a session owner that we can't handle as a host. So if the session owner did what we call a graceful disconnect, they would then say, just close the app, exit the tab, exit the game, something like that. We can handle that gracefully and immediately with no detriment to the different clients. So the service will just see that, say, hey, this person's disconnecting. They were the session owner. Pick someone else at random. Say, client three, you're the new session owner. You're in charge of things. Please take over where client one left off, and things will just keep running. So you don't have to worry about having people join or leave or anything like that. Really makes things safer to work with as a developer. And you'll see this in sort of a following demo that I'm going to do. There is sort of a little bit more of a tricky scenario where we have a hard disconnect. A hard disconnect is like, let's say your app crashes or you go into a tunnel or something like that. Unfortunately, just due to technical limitations, we can't make that instant, because there's no way to instantly detect when someone's app has crashed, because the app doesn't exist anymore. We can't really ask it if it's still alive. So we detect that. There's a small period where we're just going to waiting for the app to come back alive. If it doesn't come back alive, we're going to say, okay, we have now declared you as disconnected, and then we do the migration. It's still not as disruptive because most of the server is distributed out. Everyone else is still working. But that one client that had a hard disconnect, if they're the session owner, it'll be a little bit of a break before we can then pick back up and continue where we were. Now, that sounds well and good. Do you get it for free? Does it work out of the box? There are some caveats. Unfortunately, in order to be able to move the session owner information needs to be able to move. So there's a role that you have to play as a developer to really make sure that host migration works for you. But I think the trade-offs are well worth it, and this is something that you really want to consider when you're building your distributed authority game. Network variables are the key to this. So private state, something that is private to a client that is important that another client might need to know to pick back up and continue the game. It's your responsibility as a developer to synchronize that. And you would set that up through network variables. They don't need to be too complicated. They don't need to have a ton of stuff, but anything that's private, that's important to the game, that the session owner might have, you need to sync up with network variables. And those network variables gets transferred via ownership as the host migration system happens. With that, I do have some nice announcements, which is that with the latest versions of netcode for game objects, we've updated network variables to make them a lot more powerful and a lot easier to use, so that it's less of a burden to put things in network variables to really get the advantage of host migration. First of all, they only update when they're changed. They're very much Delta aware. They're not gonna, if it's stuff that's sort of set up at the start of the game, then the updates are only gonna send at the start of the game. They're not gonna consume more bandwidth by using more network variables, as long as you're not adjusting them too constantly. And they support a much wider selection of types. So previously, if you were using network variables, you could use primitives or you could use a network list, but there was a bit of a problem when you wanted to get into dictionaries and stuff like that. That's no longer the case. We support collections, lists, dictionaries. You can put more complicated types in your network variables out of the box and have everything synchronized. So it's easier for you to really put your game state into network variables and get full access to host migration when you need it. Now, let's show this working. I think it's really important to sort of see the sort of wow factor of what host migration can do compared to what the status quo was. So I'm not going to be working in the editor, and you'll see sort of why. It works fine in the editor. I just need to crash some stuff and really go into some harder examples. So I have a pre-built version of exactly the same social hub. I just built it earlier this morning from the build menu, so there's no special tricks playing here. And I'll connect my player one here, and we'll do demo 3. We'll start up in our social hub scene, waiting for that to connect. Now, perfect. We've connected in. We have our player. Now, we have the session owner is not front and center. It's not something that you would show the user or tell them about or anything like that. And because of that, we have to do a little bit of reasoning to follow what the session owner is in this scenario. Here, we know that there's only one player, and we know that there's one session owner, and they're the first to connect. So I know that player 1 is the session owner for this system. Now I'm going to go to player 2 and connect into the demo 3 room, same as before. So I've got my player 2. We're connected. Everything as you'd expect from before. But we know that we have a distributed session. We also know that player 1 is the session owner right now. Because it was the first to connect, it's the one running. Now, if I was in a peer-to-peer system and player 1 disconnected, player 2 would be done. That client would have to close. They'd have to start a new session. If it was a dedicated server, if that dedicated server crashed, both players would be done. There's no recovering from that in the current tool set, and we have to start a new session. But let's go to the menu, and I'm just going to exit to the main menu for player 1 here. And you'll see player 2 is still running. Everything's still continuing on. Didn't notice a thing. Player 1 just disconnected like it normally would. Well, let's add a player 3. So we got player 3, and we're going to connect into demo 3 here. I know now that player 2 has actually become the new session owner and is still running things. And player 3 is connected through, and it just keeps running. And as long as there's at least one person in the session, you can just kind of keep running this as long as you want, have things run through. And you can even see the difference in the network bandwidth. When the new player connected, we're uploading less data, less things are updating, the bandwidth will change. And if I disconnect, you'll see the bandwidth change again. And this is really sort of the magic sauce. Things just kind of keep working and you don't have to worry about it. You're not worried that, oh, what if the wrong player disconnects or something like that? Now let's go be a little bit mean. So I'm going to open Activity Monitor here on my Mac. And hopefully I can find the right one because we know player 2 must be the session owner because it transferred that way. And I'm going to hard crash this one. So I'm going to force it to quit. I got the wrong one. Please hold. Okay, I know this one is the right one now because I just got the wrong one. So let's do a player 4. Connecting into demo 3. Player 4 is in, we're still back, everything's moved. I don't want to lose that button. There we go. So now we're going to force quit player 2. There we go. So you can see here, player 2 is still sitting there for a second. It was the session owner. It's we can't instantly detect that it disconnected, but this is a crash. Like you've gone into a subway tunnel, there's no more internet, things have cut out. Worst case scenario for a multiplayer game, but we still managed to handle that. So player 2 disconnected, player 4 is the new session owner. Things are still running. It's not catastrophic. And it just kind of keeps working, which is kind of amazing if you're used to the old status quo where it doesn't keep working. That's that demo. Finally, let's talk a little bit about the service. So there is some tooling and some extra bits that really are required to make this work, to allow us to have host migration, to allow us to have that connectivity distribution. And that's called the multiplayer backend. You get some stuff for this. Like it's not just we need to have it for the actual game, but we're also looking into the future. What is going to happen when you're building your game with distributed authority? What's valuable, what matters? And the first thing is you're going to eventually launch your game. I think that's the goal for most people, is to launch a game and ideally have more than a few people playing it. We offer global availability out of the box. So you want to have servers close to whoever's playing. You want to distribute it around the world. Distributed authority, the main server, is globally available for any region that you need, and we're automatically going to pick the best one. So if you're connecting in Asia, Australia, Europe, North America, South America, you have servers near you, your distributed authority game will work, and it'll make sure that it's as low a latency as we can get, and we automatically determine the best region. So quality of service calculations are done every connection to make sure that the right servers are picked for the right players. It also hooks in with Matchmaker and stuff like that, as normally would. And it scales automatically to meet your needs. So you don't have to worry about, oh, do I have enough servers? Oh, anything like that. We're just going to scale up. If you ask for more servers, we're going to give you more servers. It's going to scale up. You're going to get access to whatever you need. And as you become successful, everything just grows with you. Easy multi-platform support as well. So running on a desktop is one thing. Running on platforms, going a little bit further, like we want to target things for most cases. And we support different platforms out of the box. So we make sure that we handle the edge cases, handle the complexity. Desktop, mobile, web, everything just kind of works. It's out of the box, it's available, and the service just kind of takes care of the nitty-gritty details behind the scenes so that you have a consistent experience across the different platforms. Even certificates, stuff like that, you don't need to worry about anymore. It's just one system for all the different platforms, and it just works. In terms of authentication and authorization, we live in a world where those things are not optional anymore. You can't have a game where anyone can connect, and there's no checking, there's nothing like that. You're going to get cheaters, you're going to get a bad time for your players. So we handle both of those cases out of the box, and you can extend it to match what you need as a developer. Authentication is handled by Unity Gaming Services. It's our cloud services, distributed authority is part of it. It's extendable. You can pull in your own auth providers, stuff like that. You can use first-party providers that we support out of the box, or anonymous providers if you're just prototyping and you want to go quickly, stuff like that. Authorization as well. We make sure that the players who are connected into a session are supposed to connect into the session. It's handled via our session system, which is Lobby. You can extend lobby. There are ways to make sure that you control who's in the lobby. And when you do that, distributed authority is very much aware and will follow your decisions, kick players, that sort of thing, and make sure that only the players who are in the lobby are allowed to join the session. Custom authentication flows and authorization flows are enabled by building off of these building blocks that you're already familiar with for your Unity services. In addition, a service gives us a lower round trip time. So we can start to take some of the benefits of having a dedicated server of strong networks, faster pipes, stuff like that, and give that to you as a user. Dedicated servers are the best case because you're talking to a server. You don't have to worry about client to client round trip times. They don't have internet that you might want to trust. And having a dedicated server keeps everything nice and consistent. If you're using Relay, or some sort of relay mechanism for peer-to-peer, that network time matters because you're then going to go up to a server, down to another client, back to a server, back to the original client. So when you're having a peer-to-peer system, the network latency is never always as best as you would want, and you can never really quite get to dedicated server levels. Distributed authority, depending on the use case, has a much lower round trip time. So if you're talking service to client, so just updates straight from the service to the client, that's the same as having a dedicated server. It's a half RTT. If you're talking client to service, then it's a similar system that you're going to talk to straight up to the service with a half RTT. And it's only in the cases where you're going client to client that you have to pay the full peer-to-peer networking cost. So we by giving you a service, we can really make things a little bit more consistent and make things a little bit quicker in your game updates, stuff like that. Now, this is great. You've seen all the demos. There's a lot of cool things, but we want to get started, right? Everyone wants to sit down, be a developer, and build whatever great ideas that they have. So we do have a bunch of resources available. So I'm just going to open up some of these links here. For started, we have quick start guides on distributed authority. The netcode for game objects, package, documentation, everything's been updated for distributed authority as you need. And you can really walk through, start setting up your own distributed authority, understand all the code, everything that works through, and we'll guide you along that process to make sure that you have access. Yeah, I opened the shell file in the links just so I don't forget which ones, and I always open them at the right times. We also have the new netcode for game objects package. Package is launched, package is released, it's accessible. Distributed authority is built in, baked in, and you can use it as needed. So feel free to pull the packages, use what you need for developing your game, and start experimenting with distributed authority or just some of the other features that we've added to the netcode. And then finally, the sample that you've seen me doing the demos on is also available. It's open source. It's up in our bite-sized samples. It's called the Distributed Authority Social Hub example. You can go try it locally, connect a couple of pigs, toss some boxes around, or use it as a base. Build up on it, adjust it, and start working on your game. Learn how distributed authority works and how more complicated bits of game can be put into things. Yeah, once again, like I was saying, distributed authority is live. You can also use this QR code if you want to just scan and go right into the distributed authority sample. We have samples, we have docs, we have packages, everything that you need to get started is available. Yeah, really hope that people want to try it out. Think that what we've built here is cool, and I want to see what people are able to build with this because I think it's really cool technology. We're also offering, we're still in beta right now. So until January 31st, we have a very generous free offer that you can use, you can try out and just experiment as much as you want. There's tons of available space for it. And yeah, we want to get people started on distributed authority. That's pretty much everything. I hope you guys found that super interesting and really enjoyed seeing and learning a little bit more about distributed authority. I think my colleague Noel is going to pop in as well, and we'll just take some QA questions. Yeah.
Yeah, so just to answer, I've been noticing a lot of people asking about like the type of game. What kind of game would you build with distributed authority? And the best answer I could give you is if you're looking to get like a really high precision, like a racing game or a flying game, anything that requires uh, any form of like say lots of collisions and everything has to be perfectly in sync, then distributed authority is not going to be the model that you're going to want to use for that. That might be like an ECS thing, and it's like a dedicated server really to have those kinds of things. However, there's a lot, I mean, you can, depending upon your game, there's a lot of mileage that you can get from it. And you can actually get collisions. There's been some additional features that have been added to help with that and to reduce the collision overhead that sometimes comes with mono behaviors. Um, and you'll have to explore that. There's an additional collision manager where you can register with that to get collision contacts, and it gets pushed off to a job. So then all your collisions are handled in the background of a job as opposed to being invoked on every mono behavior instance. So from that perspective, if you're looking for like a competitive type of a title or anything that requires high precision physics or any kind of a high precision simulation, then it may not be the model. But for a lot of the different genres, game genres, it actually does help. And the visualization in terms of what Dominique was talking about, um, because you can, I don't know, anybody that's used NGO, they may have run into the scenario of the spawning and where you're like, okay, well, I want to have an owner authoritative thing because I want to have my player to be, I want to have instant feedback on the player side. But then it's like, okay, but now I want to be able to shoot something out, or I want to have some kind of projectile come out um, from that player. And it's like, oh, but I have to send an RPC to the server, and then the server has to spawn it. So I got to figure out if my player is running, then I have to figure out where that projectile needs to be spawned in front of that player to make it all visually synchronized. With distributed authority, you just basically you instantiate and you spawn on that client, and then that synchronizes with all the rest of the clients. So I'm trying to get a couple of questions in one answer here. Sorry for taking so much, so much
All
time.
good, Noel.
Yeah. So that's. I hope that answers some of the questions. Oh, and there's another one. Mark Hannicott asked about upstream bandwidth increase, and I'm not sure if that's really if that's so you are going to have an increase in your upstream because you're distributing all the different objects across the clients. So the state updates for those objects are basically being pushed from those clients to the service, and the service is routing that information and synchronizing all of the clients. And that's really the Dominique did a really great job with the service, and it's highly optimized. Actually, I haven't seen something process messages that quickly before. I've been doing stuff like this for a really long time. Um, but so in terms of upstream, you will see a bit of an uptick in the upstream. But then if you like use I actually added in our 2.0 branch, there's like an examples folder in the repository, and there's a thing called the ping tool. And you'll actually see like, say you have two players connected in a whole bunch of objects, and they're pretty much a 50-50. We're upstream, downstream, maybe that downstream is a little bit bigger, but for the most part, it's about a 50-50 split. And you'll see a third client connect in, and you'll see the upstream get reduced. And then as more clients connect, you'll see the upstream get reduced down because they're distributing that out there. Now your downstream is going to be kind of increased because you're having to receive the state updates. So it's really kind of the more clients you have connected, the smaller your upstream is going to be.
Yeah, I'm seeing a question here of whether this works with other systems alongside things like PlayFab matchmaking. So distributed authority does work well with other systems. You have to transition at some point. So you'll have to kind of bridge the gap into the distributed authority world, but there's nothing saying that you can't use a third-party system for authentication, authorization. There's ways to get those. another third-party system for matchmaking, however you want to pull that match together, that's up to you. We make it easy using Unity services, but there are ways that you can integrate other services, like you mentioned PlayFab here, or whatever, if you have a custom one or something like that. Those can be added in as needed. And there's really a lot of ways that we can configure how you want to run this system. So I see a question on costs. The pricing is available. If you go into, I don't know off the top of my head the exact pricing, but you can go up online into our pricing pages at Unity and you'll be able to see what the price is, what the cost is, what you'd expect to get for usage, stuff like that. And I'll take the opportunity to call out, yeah, we still have a very generous beta right now. Up until, I believe it was January 30th, up until the end of the beta, you're not going to get billed, and that continues forward. So there's still a free tier available, and then the cost is going to be on top of that. I see, does this work cross-platform? Yes, the service does work cross-platform. The service doesn't really care what platform you're connecting in on. You can do cross-platform connection, stuff like that. Any of the platforms across, they can connect to different versions of the service, stuff like that. And it'll synchronize itself as long as they're the same, roughly the same builds. Like you can't have two different games connected on the same system, but as long as they're compatible with each other, it'll work cross-platform.
Hey, Dominic, Noel, we have about 3 or 4 questions regarding addressables and how that would interact with a distributed authority game.
Yeah. So let's see. Addressables as assets like network objects, those types of things. That would still work as it does with client server, where you can preload the addressables. And that's just something that you have to actually, it's not like an automatic integration type of thing. In terms of the loading scenes, that is not something to support, I think, in client server either. So it's the same kind of support that you get from the typical NGO you would have in distributed authority. You'd still have to go through the same process, but the one thing that would not be supported is, like, say, an entire scene that is to be loaded, and that's just a limitation of the scene manager. Oh, also, I just wanted to answer the one about the Diablo 2 type of like a dungeon crawler, and it would make it is a good network topology for that type of a game, especially co-op. Co-op, it's a great topology for co-op type games.
Excellent. I got a question about whether you can connect to a server of your choice, say if devs are working in different servers, regions, countries. We offer QoS out of the box. So if you don't tell us what server you want to connect to, we're going to go determine the best one and do that. You can also override that. So you can say, I would prefer to go connect over here. That could be halfway across the world if you wanted, or it could be right next to you if you wanted. That's still up to you. It's just we have a default that we're going to figure out the best server, and you have complete control if you want to override that default and specify which server you want to be connecting to. I see we have time for one more question. Noel, do you have one that you want to grab?
There's so many good questions. I've been looking at this and trying to find a really good one. Oh, well, some of these questions are really good ones, and like Dominique said, that the service is still beta, and there's obviously some things like that we're still looking at, and we're investigating the best way to provide additional options and or possibilities with distributed authority. So do know, if you don't see it, that we most likely have contemplated it, and we're looking at how we can bring the best experience to you.
Excellent. I think that's about all the time that we have today. Once again, 184 participants. That's a huge turnout. I'm super happy with that. I hope you guys all learned a ton, This will be available, links will be available, everything will be accessible. So don't worry about that. And thank you all for your time, for listening, for engaging. This was really great. And I look forward to seeing what you guys build with Distributed Authority. So have yourself all a wonderful day. Take care.